Alright, so I'm going to be talking about the sample question from the Bayes dissociation constant. So this is the equation that we're given, and this is hydrazine over here. So we're going to set up the ice table for it. So I, the C, and the E. So we are told that in the beginning we have 0.100 molar concentration of the hydrazine. This is in liquid form, so this does not matter. And as we know, the products initially start with 0 concentration each. The change, we know that this is going to have a minus x change, so we're going to end up with 0.100 minus x. Here, we know we're going to add an x, same here, because the coefficient is 1, so our final values are going to be x and x respectively. So, and we also know that the Ka of this equation is 1.7 times 10 to the power of negative 6, and that's the Kb. So with this, we know that if it's 10 to the negative 6, we can use the approximation method, which means we can assume that this x is essentially 0, which means this is just 0.1 molar concentration. So now we can do our equation. So we know that Kb equals products over reactants, so concentration of products over the concentration of reactants. And in this case, we have the concentration of the OH, concentration of N2H5 plus, there, and then we have the N2H2. So if we go here, the Kb of this, here we know that these two are unknown, so we know that it's x times x, which is x squared, and under we have the initial concentration that we were given, so 0.100 m, and what we also know is the Kb of this formula, which is 1.7 times 10 to the power of negative 6. So if we work this out, it's x squared, or it's x under the root 1.7 times 10 to the power of negative 6 times 0.10 molar, and the x for this will come out to be 4.1 times 10 to the power of negative 4. We also know that this is what goes here and here, and so the question, now I'm just going to erase this because I need some space. So now it's asking me to calculate for the pH, so we know that we're going to calculate the pOH, which is negative log concentration of the hydroxide. We know that we calculated it before, so it's the negative log of 4.1 times 10 to the power of negative 4, and so the pOH comes out to be 3.48, but the question asks us for the pH, so we do 14 minus 3.48 is the pH, and so the pH equals 10.62. Okay, so now part B asks us for the Ka of the N2H5 over here. So we know that the Ka times the Kb will give us the Kw. Now, if we isolate for the Ka equals Kw, which is a constant, over the Kb, which we have earlier. So Ka equals 1 times 10 to the power of negative 14 over 1.7 times 10 to the power of negative 6, and the Ka for this comes out to be 5.88 times 10 to the power of negative 9.